Hi, so in this video we will go through how to make an introduction for your report. So when you approach your introduction, what you're doing is you need to think about how do you set the scene. Okay, so you need to establish what is the niche for your product, what is the gap that you are filling. To show you how to do that, I would like to start with some theory and some reasoning behind my thoughts, and then afterwards show you an example. So think of your introduction as a funnel. So the person reading your report, they were just doing something and now they need to focus. Help them focus by funneling their thoughts towards your project. The reason why you want to describe the environment and the general topic is also because your supervisor or the censor might not know the industry that you have been working with. Set the scene and establish your territory. The way you do that is state first, very early on, the general topic and give some background. There will be a lot of assertions in an introduction, but give references to those assertions. Then describe the inhibitors and opportunities for your product, for a new solution to this market that you just described. When you establish your niche, you need to clarify the focus of your work. So what I mean with that is show why there is a need for more work to be done. Explain that from the problem analysis. What are the challenges? What is the gap that your product is trying to fill? Finally, it's a good idea when you evaluate the current situation to make like a pro-con list of, for example, your product or the situation or the problem. So now I would like to show you an example and try to explain why I think it's well done. So the example I would like to present to you now is a group of my former students who made an autonomous surface vehicle. We did that together with some Arctic researchers, and these Arctic researchers made a publication together with the students. And I think this introduction is particularly well made, so I would like to use that as an example and try to explain to you, given the theory I just presented, why do I think this is a good example. So here we have it. So we start with unmanned surface vehicles have been used by militaries since World War I and II through early unmanned surface vehicles, that's USV, used remote control and lacked autonomous navigation capabilities. Now here, that's a really good example of funneling, right? We go all the way back to the World War and then we funnel you down to, okay, we have the remote control, they lacked autonomous navigation. Modern autonomous surface vehicles differ from USVs in their unattended autonomous navigation capabilities. Currently, a wide variety of ASVs are in use, and their development remains an area of active research. So what we are doing here is we are setting the scene, we are establishing the territory, we are telling the reader, okay, where are we in the world, in very few sentences. Now comes the part from the market analysis. A number of commercial ASVs are available and their manufacturers include, and then we have a long list. So now we are marking up what's the competition. Again, this is establish your niche, what are your competitors, what are you up against. Open source ASVs include those using the autopilot boat configuration at various university projects. Okay, so now I'm kind of getting the idea. We are talking about an open source project. Modern uses of ASVs span a range of applications from water quality monitoring to harmful algal blooms to enhancing maritime situational awareness, life-saving operations, bathymetric mapping. Okay, so now we have an idea of what are these used for. Again, we are establishing the territory, setting the scene. For the overview of modern SVs and their applications, we refer the reader to 12. So here we give a review. So if they want to read more, go here. Okay, so now I get the feeling we are done now. We start a new part here. Greenland has an extensive coastline that remains poorly charted, especially in shallow areas. So we are talking about Greenland here. And we are starting to approach what is the problem that we want to work with. Bathymetry measurements in Greenland are needed, especially in coastal environments, to estimate the potential distribution of macroalgae and seagrass, which contribute to oceanic carbon sinks. Additionally, ocean current observation near icebergs and marine terminating glaciers are necessary to estimate melt driven by forced convection. So here we have another application for this unmanned surface vehicle they are proposing. Icebergs and glaciers, as well as shallow nearshore waters, present a significant safety risk to manned vehicles. Okay, so here we are addressing why not just use a manned vehicle for this. While there are many SVs in use, we required a small, portable and agile vessel suited for operations in shallow water and deployment from small 10 meters workboats in Greenland. Okay, so now we are saying we know there are these competitors, but the reason why we develop our own is because of these specific needs that were not met by these competitors. So you can see effectively how we funneled the user down and we explained what is the scene, what are we going to talk about, what is this report about, what are we going to address, what is the problem, why is it an important problem, and we told what are the challenges. We identified a gap. So now the user is prepared to read, okay, so how did they fill this gap? And that's exactly where you want them. Thank you.